So for 3-2, we're going to be solving systems of inequalities by graphing. I'm sorry if you don't like to graph, but it's all graphing today. So first, I kind of want to review, how do I graph a linear inequality? So for starters, you know, I kind of have y equals mx plus b here. I'm going to graph that. So down 4 is my y-intercept, 1, 2, 3, 4. And then since my slope is 2, that means I get to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And today you are going to go ahead and make sure you take that all the way across your grid. And then I looked at this inequality sign and said extra ink, and this doesn't have extra ink, so I'm just going to make it a dashed line. Sometimes connecting every other dot will let you get a dashed effect there. And then again, I like to plug in my favorite point, which is 0, 0. And simplify from there. So 2 times 0 just cancels. Is 0, question mark, less than -4? And no, that is not true. So I do not get to graph 0, 0. So I would be shading over here. Okay, did you know that there's actually another way you can show shading on a graph? If you recall from my number line, I said you can shade either by coloring like that or by just drawing an arrow like that. Well, it's the same thing on graphing in the two-dimensional world. What I want you to do for just a minute is point arrows out that way. Okay, that it should shade that way. That's what we're going to do today. So let's check out a system of inequalities. I'm going to try, actually I'm going to try 1b. So I'm probably going to start with the bottom one because it's linear. That's a little easier for me. Y-intercept's at 5, and it should go up 4 to the right 3, but I'm at a graph, so I'll go the double negative here. Down 4, left 3. 1, 2, 3, 4, 1, 2, 3, somewhere over there-ish. And it should be a dashed line. Something like this. I know it's not perfect, but... And if I plug in 0, 0, 0 is less than 4/3 times 0 plus 5. Is 0 smaller than 5? Yes. So it's going to shade kind of right and down-ish. So now I'm going to go ahead and graph the absolute value, and maybe I'll do it in a different color so it's easier for me to see. This is going to be one of those, I say graph, you say table, and again we kind of learned last time when we did absolute values to use that H value. Since it's not written, it's just going to be 0, so I'm good to go there. Kind of made my table weird, but there it is. And I can just plug in. The absolute value of 2 is 2. The absolute value of 1 is 1. Absolute value of 0 is 0. Absolute value of -1 is 1. Absolute value of -2 is 2. I was just taking all those numbers and plugging them in right there. I did it real quick in my head. Plot those. Oops. Plot them correctly. Okay, and since it's absolute value, I know that that pattern just continues on forever. Again, today you are going to want to take it all the way across. And extra ink, it looks like I get to just connect the dots with a nice straight solid line. Oops. Like so. And then do the same thing. Plug in 0, 0. Is 0 smaller than... Oh no, I can't use 0, 0, can I? Look, this is where I ended up. 0, is 0 bigger than or equal to 0? You can't do that because, of course, it's going to be on the line. You need to pick a point that is not on the line. So maybe I'll pick 0, 1. Let's try that. So is, if I'm choosing 0, 1, this is x, this is y, 1 greater than or equal to the absolute value of 0. Is 1 bigger than 0? The answer is yes. So now I do get to shade towards that, and again I'm just going to draw those arrows. And then you are asking yourself, what part of the graph does everything get to shade? So if you can see it just based on the arrows, that's awesome. If you're having a hard time visualizing it, the green all shades this way, right? The blue is all shading this way, right? Where do they intersect? Of course, that intersecting region is right here. So that is what you would get to color as your final answer. So to show what I'm expecting then on your homework, clear all that out, you would be just simply coloring like that. That's all we're doing today. They do kind of take a while. I do want to show kind of an example of this one. I'm going to do it super quick. If you graph these, I got to go by twos, I guess. 2, 4, 6, 8. So I can have my 8, down 4 over 1, down 4 over 1. Oops. Okay. Down 4 over 1, down 4 over 1, down 4 over 1. Okay, and so this is a dashed line. I know I did that super quick. Just trust me on this. When you go to decide which way they shade, they're going to shade like this. Notice they are parallel lines. So the lines are never going to cross, and there's no way that that middle section, I mean, it's never going to become a shaded region. So this one is no solution. All right, and that, I believe, is all for today. I want to do that example in class.